Hello and welcome to today's class. I will be teaching you guys what subnetting is. So, first of all, I'm going to give you a brief introduction about myself. My name is Chagbe Emmanuel, and I'm a student of computer engineering. So, let's get into the classes. Thank you. About subnetting today. So, what is subnetting? Subnetting is a practice of dividing a network into two or more smaller networks. It is a method of dividing full network address classes into smaller pieces. So, why do we need subnetting and who ate all of our IP address? No, just joking. Let's continue with our class. So IP address 4, version 4, uses 32 bits for its internet protocol. That means it can support about 4.29 billion addresses. And that may seem a lot, but all of those 4.29 billion addresses have been already assigned to various institutions leading the crisis we face today. So we will be looking at why we need subnetting. So first of all, we need subnetting to increase routing efficiency and to enhance security of the network and reduce the size of the broadcast domain. And then subnetting is another method of managing IP address. So as we asked earlier on who had our IP address, we need to manage them in order to reduce the waste of the IP addresses we use, since we have limited number of IP addresses. And then also has prevented complete IP address exhaustion. It is impossible to cover TCP IP without mentioning subnetting. So, it is not always necessary to subnet a network. However, for large and extremely large network, subnetting is required. So we need to divide our network into more than one network so as to be able to manage it very well and reassign IP addresses. Each network is treated as a separate, each subnet is treated as a separate network. Subnetting a network means to use the subnet mask to divide the network and break the large network up into smaller and more efficient and manageable segments or subnets. With subnetting, the network is not limited to the default class A, B, or C network masks, and there is more flexibility in the network design. Subnet address increase network portion plus a subnet field and a host field. The subnet field and the host field are created from the original host portion for the entire network. So here is an example of what subnetting looks like. Imagine you have a pixel and you have to you have a group of friends and you have to divide that pixel into different segments in order to be able to have additional number of pieces that you could be able to give to each of those individual friends of yours. So supposing you have 4 friends and you have just 1 pixel, you would have to divide the pixel into 4. pieces to be able to allocate to each of your friends. So I want you to picture subnetting to be the same thing as dividing the network, dividing the pixel into 4 different pieces to be able to assign to be able to give to each of your friends. So I created an example here which I would want us to go through, and then our given IP address is 192.168.1.0/28. So we have 10 hosts for network A, we have 5 hosts for network B. So we'll be looking at how we could subnet this network. So let's get started. Network A, since we have the number of hosts to be 10, we have a formula which we use. It's going to be 2 raised to the power of n minus 2 should be greater than or equals to the given number. So in this case, when we use 4, we can say 2 raised to the power of 4 negative 2 is greater than or equals to 10. So when we do the calculations, we'll discover that we have 14, it's greater than or equals to 10. So therefore, when we have 2 raised to 4 equals to 16, that would be our network spacing. And therefore, network B as well, we have 2 raised to 3 minus 2 is greater than or equals to 5. So therefore, we have 6 is greater than or equals to 5. But when we raise to 3 raised to the power of 2 raised to the power of 3 will be equals to 8. So therefore, we'll be having all of these with our IP addresses with this spacing into our table. So we'll get into our table now to see how we made our hosts, our broadcast domains, and all of that. So in our table here, we can see that we have our networks on the left side, which is network A has 10 networks, and then network A has 10 hosts, network B have 5 hosts. So the IP address, the first IP address, first network address given to us was 192.168.1.0/28. So with our spacing, which is 16, we know that the last usable IP address, the broadcasting domain for us would be 16 because of the fact that the following address we'll be having would be 192.168.1.16/29. So we have from .192.168.1.1 to be our first host address down to 192.168.1.14. Then our broadcasting domain will be 192.168.1.15. So since our spacings from the calculations we made, the spacing we had was 16. Therefore, the next IP address, the next network address for us will be 192.168.1.16. So for the second one, since our spacing is 8, we will add 8 plus 16. So when you add 8 plus 16, you will have 24. So when you have 24, that means your next address would be 192.168.1.24. Therefore, our broadcast address will be 192.168.1.23. And then our usable address in between will be 192.168.1.17 to 192.168.1.22. So in between here, we have all the number of IP address required, number of network address required to cater for each of the networks. So for network A, we have 14 addresses, although we only need just about 10. So we're going to be using only 10 and 4 would not be used. For network 5, we have from 17, we have from 17, 18, 19, 20, 21, 22. So we need only 5 addresses, one will not be used. So that is how we have been able to subnet this network into different network addresses and then the host addresses with each broadcasting domain. If you notice very well from the previous slides, we have for the network, the host networks, which we had 8, our prefix was 29. And for the ones which we had 16, the prefix was 28. So most of the times it's good to use the table in order to be able to figure out your subnet max so as to be able to know exactly what it is. An example of the implemented version of what we just did now using a packet tracer. So we have been able to configure the network and assign each of the usable network onto each of the hosts required. So we have 2 switches. So 2 of the switches, one switch catered for 10 networks, the other switch catered for 5. One switch catered for 10 hosts, and the other switch catered for 10 hosts. So we have our router here and our PC. So that's how we have been able to practically implement this into packet tracer. Watching, I do hope you learned at least something. Thank you.